Case 2. If Fn is exact n log Ba, then what do we do? We want to prove Tfn equals n log Ba log n for any base, constant base. Here it's just log n, log 10. Okay. We use the same equation we derived before case 1. Tfn equals n log Ba times C plus sigma, the summation from 0 to log Bn minus 1, a to the power of I Fn over Bi. We still focus on the second part. This case is a little bit simpler than case 1. And we want to use n over B of I to replace Fn over Bi, n over Bi log Ba. Okay, without a little epsilon, here. So I have some detailed slide for you. Let's say here if Fn equals n log Ba, it also means that Fn over Bi equals n over Bi log Ba. Okay, just use n over Bi substitute n in the first formula here. Okay, after that, we do the same thing. We do the distribution log Ba to n and the log Ba to B over I. Let's say we can, we have more beta ones here. Say here, we do the distribution, then we get log Ba, Bi log Ba, and then we do the swap, exchange the order. After that, we swap, swap log Ba with I, and in order to extract I for both A and B, say. See here, swap, okay, and we will extract I. So because B log Ba equals A, that means this item will be A. Okay, A and A will become 1, okay, to the power of I. From 0, the summation from 0 to log Bn. So can say this one is exactly log Bn, log Bn. So move n log Ba to this part. And because B is constant, so we can use any other constant to replace that. So the result for the second part of the equation will be say n log Ba times log n. And you might have the question about how about this part, because C is smaller than log n. This one is dismissed. So the only thing we left here is n log Ba times log n. BA. That's the end of the proof for second case. The proof for third case, we can continue. And the third case says Fn equals something a little bit bigger than n log BA, because I have a plus positive epsilon. So at least a little bit bigger. And also AFN divided by B less than CFN. When C is less than 1, we will have TFN equals to exactly F of N, F of N. We use the same formula here. We just want to replace the formula F N over BI to CIFN. I can show you in the next page why this one is valid. So from the AFN over B equals less than equal to C F of N, we can get F of N over B less than or equal to C divided by A times Fn. So if we do that, we will have, if Fn to the B squared will be C over A times Fn over B. So Fn over B, we replace that again. It will be C over A times C over A times Fn. So will be C to the squared and A to the squared divided by A to the squared Fn. That's why and Fn over Pi will be less than or equal to C of I divided by A to the I and the Fn. And to here, and we move A of I to the left side of the inequality. So we'll get here. After this one, and will be easier because we wanted to just want to move Fn out of the summation. We have n to the power or C to the power of I. And what is the next here? Okay. After that, we can enlarge a little bit to the infinity. We want to get rid of log Bn and less than equal to, according to, again, the geometrical progression series, this one will be 1 over C. And because we have 1 over C to the infinitive and C, 1 over C to the infinitive will be 0. So C less than 1. C less than 1. That's the case. Okay. And a little bit of detail of y and it's less than equal to here. But if we consider about this equation, the first equation, we will get T of n equals exactly f n. I have put the equation, the reason here. That is the end of the proof. And the reference you can get, it's Introduction to Algorithms, also data structure and algorithms in Java.